Preparing for a DevOps engineer at Dynatrace interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a reliable CI/CD pipeline for a microservices application? I would build the pipeline around repeatable, automated stages: linting, unit tests, security scanning, container creation, integration tests, and deployment. Artifacts should be immutable and promoted across environments rather than rebuilt. I would use infrastructure as code, protected branches, secret management, and progressive delivery such as canary releases. Deployment telemetry must include logs, metrics, traces, and business indicators. If error rates or latency regress, automated rollback restores the previous version quickly. While answering, cover source control, automated testing, artifact management, staged deployments, approval policies, rollback strategy, secrets handling, pipeline observability, and how you would balance delivery speed with production safety. Question 2. What is the difference between monitoring and observability, and why does it matter? Monitoring tells me whether known conditions are healthy, such as CPU exceeding a threshold. Observability helps me investigate unknown failures by correlating metrics, logs, traces, deployments, and user impact. For example, a distributed trace can connect a slow checkout request to a database query and a recent release. I care about actionable telemetry, not volume. Alerts should represent user-facing risk, while dashboards and exploratory queries support diagnosis. Make sure to cover predefined health checks versus exploratory diagnosis, metrics, logs, traces, high cardinality context, service dependencies, alert quality, and how observability reduces mean time to detect and resolve incidents. Question 3. How would you troubleshoot a sudden latency increase in a production service? First, I would verify the increase against a normal baseline and determine affected regions, endpoints, and customers. Then I would correlate the timing with deployments, infrastructure changes, traffic spikes, and dependency behavior. Distributed traces can reveal whether latency originates in application code, a database, or an external API. I would mitigate through rollback, traffic shifting, scaling, or feature disablement, then preserve evidence and complete a blameless root cause review. In your answer, talk about confirming user impact, checking recent changes, comparing baselines, using distributed traces, examining saturation and dependencies, narrowing the fault domain, mitigating safely, and documenting the incident afterward. Question 4. How do you implement effective alerting without creating alert fatigue? I design alerts around customer-impacting symptoms and service-level objectives rather than every infrastructure fluctuation. Each alert needs an owner, severity, context, runbook, and clear action. I use multi-window burn rate alerts for important availability or latency objectives, then suppress duplicates during known dependency failures. After incidents, I review whether alerts fired early enough and whether responders could act. Removing noisy alerts is as important as adding useful ones. Be sure to mention symptom-based alerts, service-level objectives, severity levels, actionable runbooks, deduplication, dependency awareness, meaningful thresholds, ownership, and regular review of noisy or unactionable notifications. Question 5. What Kubernetes concepts are most important for a DevOps engineer supporting production workloads? The essential concepts are declarative deployments, pod lifecycle, services for stable discovery, ingress for external routing, and namespaces for organization. I would define realistic resource requests and limits, configure readiness and liveness probes correctly, and use horizontal autoscaling based on useful signals. Configuration and secrets should be externalized. For production, I also consider network policies, least privilege service accounts, disruption budgets, node capacity, and observability across cluster and application layers. Focus on deployments, pods, services, ingress, resource requests and limits, probes, autoscaling, namespaces, configuration, secrets, scheduling, security policies, and practical troubleshooting of unhealthy workloads. Question 6. A Kubernetes deployment is stuck with pods in CrashLoopBackOff. How would you investigate it? I would start with pod status, events, and both current and previous container logs because CrashLoopBackOff often hides the original failure. I would inspect exit codes, startup commands, environment variables, mounted secrets, image versions, and probe configuration. Then I would check resource limits and dependency connectivity. If a recent release caused the issue, I would roll back while preserving logs and manifests. The fix should address the failure mechanism, not merely restart pods. Cover pod events, container logs, previous container logs, exit codes, probes, configuration and secrets, image compatibility, resource limits, dependencies, recent changes, and a safe remediation process. Question 7. How would you manage infrastructure as code across multiple environments? I would create reusable, versioned modules for shared patterns and keep environment differences in explicit configuration rather than copying entire definitions. Remote state requires encryption, access control, locking, and reliable backup. Changes should pass formatting, validation, security checks, and plan review through pull requests. I would detect drift regularly and keep secrets outside source control. Modules should remain understandable. Excessive abstraction can make failures harder to diagnose and changes riskier. In your answer, cover reusable modules, environment-specific configuration, state management, locking, review workflows, drift detection, secret separation, testing, promotion, and avoiding duplicated or overly abstract infrastructure definitions. Question 8. How do you secure secrets in CI/CD pipelines and production systems? I avoid storing long-lived credentials in repositories, pipeline variables, or container images. Instead, workloads obtain short-lived credentials through a secret manager and workload identity, with permissions limited to the required resources. Secrets are encrypted at rest, masked in logs, rotated automatically, and audited. Production and non-production credentials remain separate. I also scan commits and artifacts for accidental exposure, because preventing leakage is more effective than cleaning it up afterward. Mention centralized secret managers, short-lived credentials, workload identity, encryption, least privilege, rotation, masking, audit trails, separation of environments, and preventing secrets from appearing in logs or artifacts. Question 9. What is blue-green deployment, and when would you choose it over canary deployment? Blue-green deployment maintains two production environments. I deploy and validate the new version in the inactive environment, then switch traffic, making rollback fast. Canary deployment sends a small percentage of traffic to the new version and expands gradually based on telemetry. I prefer blue-green when rapid rollback and deterministic validation matter, provided duplicate capacity is affordable. Canary is better for reducing blast radius and validating behavior under real traffic, though it requires stronger routing and analysis. Explain both strategies: traffic switching, rollback speed, infrastructure cost, validation depth, risk exposure, database compatibility, and criteria for selecting one based on application criticality and traffic patterns. Question 10. How would you define and use service-level objectives in an engineering organization? I would define service-level indicators from user journeys, such as successful request rate, latency, and freshness of critical data. The objective sets an acceptable target over a stated window, while the error budget represents permissible unreliability. Teams use budget consumption to balance feature delivery against reliability work. Alerts should detect rapid or sustained budget burn. Objectives need clear ownership and periodic review, because a metric that does not reflect customer experience creates false confidence. Be sure to discuss user-centric indicators, availability and latency targets, error budgets, measurement windows, alerting, prioritization, ownership, and avoiding objectives that teams cannot influence or reliably measure. Question 11. How would you instrument a service using OpenTelemetry? I would instrument inbound and outbound operations with traces, record-read metrics such as rate, errors, and duration, and correlate structured logs using trace and span identifiers. Context propagation must work across HTTP, messaging, and asynchronous boundaries. I would use semantic conventions and resource attributes for service identity, version, and environment. OpenTelemetry collectors can centralize processing and export. Sampling should control cost without hiding rare, high-impact failures, and sensitive data must be filtered. Cover traces, metrics, logs, context propagation, semantic conventions, exporters, sampling, resource attributes, collector architecture, privacy, and avoiding excessive telemetry cost are missing critical business context. Question 12. How would Dynatrace help you investigate a distributed production incident? I would begin with Dynatrace service flow and user impact views to identify which transactions and services are degraded. Distributed traces can connect front-end symptoms to back-end calls, databases, or external dependencies. I would correlate logs, infrastructure metrics, deployment events, and topology changes, while using Davis AI for anomaly detection and probable cause guidance. I would validate that guidance against traces and timelines, then use the same telemetry to confirm mitigation and recovery. Mention distributed tracing, service flow, Davis AI, topology, logs and metrics correlation, deployment markers, user impact analysis, anomaly detection, and validating hypotheses rather than treating automated recommendations as unquestionable conclusions. Question 13. What is the purpose of Dynatrace OneAgent, and what deployment considerations matter? Dynatrace OneAgent provides broad host, process, application, and dependency visibility with automatic instrumentation for supported technologies. I would deploy it consistently through approved host packages, container images, or Kubernetes operators, depending on the environment. Before rollout, I would check permissions, supported versions, network connectivity, overhead, and data privacy requirements. After installation, I would verify process groups, service naming, trace continuity, and alert behavior rather than assuming installation equals useful observability. Discuss automatic instrumentation, host and process visibility, supported environments, permissions, resource overhead, container and Kubernetes deployment, version management, data privacy, and validating coverage after installation. Question 14. How would you implement monitoring for a Kubernetes platform and its applications? I would monitor the platform in layers: control plane and node health, cluster capacity, pod scheduling, workload restarts, resource saturation, and application golden signals. Kubernetes events and audit data help explain scheduling or policy failures, while traces and logs expose application behavior. Dashboards should separate platform and service ownership but preserve correlation across layers. Alerts should prioritize unavailable workloads, exhausted capacity, and customer impact instead of firing on every transient pod event. In your answer, cover cluster, node, workload, application, and user layers, resource saturation, control plane health, events, traces, logs, dashboards, alerts, and ownership boundaries between platform and service teams. Question 15. How do you approach incident response and post-incident learning? During an incident, I establish impact, assign roles, create a communication channel, and prioritize mitigation over perfect diagnosis. I use dashboards and traces to test hypotheses while keeping stakeholders updated with facts and next steps. After recovery, I write a blameless timeline, identify contributing factors, and create prioritized actions with owners and deadlines. Effective follow-up includes automation, safer defaults, better alerts, or documentation, then measuring whether those changes improve reliability. Cover detection, triage, incident roles, communication, mitigation before diagnosis, escalation, timeline capture, blameless analysis, corrective actions, ownership, and verifying that improvements actually reduce recurrence. Question 16. How would you optimize a slow or unreliable deployment pipeline? I would measure queue time, stage duration, failure causes, reruns, and time to deploy before changing anything. Independent tests can run in parallel, dependencies can be cached, and immutable artifacts should be reused across environments. I would quarantine and fix flaky tests rather than hiding failures, while selecting fast feedback tests for pull requests and broader suites before production. Ephemeral environments can reduce contention. Optimization should improve lead time without weakening security or release confidence. Mention pipeline measurement, parallelization, dependency caching, test selection, reusable runners, artifact reuse, flaky test isolation, environment provisioning, queue time, security checks, and protecting quality while reducing cycle time. Question 17. How would you design a rollback strategy for an application with database changes? I avoid assuming database changes are instantly reversible. I use expand and contract migrations, add compatible fields, deploy code that supports both schemas, backfill safely, switch behavior with a feature flag, and remove old structures later. Application rollback should remain possible without requiring database reversal. For destructive changes, I require backups, tested restoration, validation queries, and an explicit recovery plan. This approach trades some migration complexity for much safer releases. Be sure to discuss backward-compatible migrations, expand and contract patterns, versioned schemas, feature flags, data rollback risks, backups, validation, transaction safety, and separating application rollback from database reversal. Question 18. How do you manage reliability and cost when autoscaling cloud workloads? I scale on signals that represent workload demand, such as request rate, queue depth, or latency, rather than CPU alone. Requests and limits must reflect actual behavior, and cooldowns prevent oscillation. I account for startup time, quotas, dependency capacity, and graceful degradation during peaks. Cost dashboards and right-sizing identify waste, while load tests validate policies before production. Spot capacity can reduce cost for tolerant workloads, but critical paths need resilient fallback capacity. Discuss demand signals, horizontal and vertical scaling, startup time, resource requests, cooldowns, quotas, spot capacity, graceful degradation, cost monitoring, load testing, and preventing scaling loops or under-provisioning. Question 19. How would you handle a production deployment that passes tests but causes customer errors? I would first quantify affected endpoints, regions, versions, and customers, then stop further rollout. If possible, I would disable the feature or shift traffic to the previous version while preserving evidence. I would compare traces, logs, error rates, and business metrics between versions to isolate the change. Communication should be concise and frequent. Afterward, I would improve test realism, canary gates, contract checks, or observability so the same gap is less likely to recur. Focus on immediate detection, blast radius assessment, feature flags, traffic rollback, telemetry comparison, communication, compatibility issues, deployment safeguards, and learning how tests or observability failed to represent real conditions. Question 20. How would you improve DevOps collaboration between development, operations, and security teams? I would create shared ownership around service outcomes rather than making operations a final approval gate. A platform team can provide paved roads for deployment, observability, secrets, and infrastructure, while policy as code enforces security consistently. Developers should receive fast feedback from production telemetry, and incident reviews. Reliability objectives align priorities across teams, and self-service reduces handoffs. Governance remains important, but automation makes the secure path the easiest path. Mention shared ownership, platform engineering, paved roads, infrastructure as code, policy as code, common reliability goals, self-service workflows, feedback loops, documentation, and reducing handoffs without weakening governance. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.